Right. Well, firstly, welcome everybody. Thanks very much for joining us today for this webinar covering Qlik AutoML. It's great to have everybody back on the webinars. We are kicking these off again. We've got 3 more planned over the next 3 months, so do keep an eye out for those. We're looking at doing one on sentiment analysis, hybrid data delivery, and some of the new authoring options. So if there's other things that you would like to see, please do email in, and we'll do what we can to accommodate you, or put something in the chat. So let me make a start. So agenda, I was going to do a brief introduction, talk about some housekeeping, how you interact during this webinar, and then most of the time will be spent with my colleague Mats, who will be demonstrating the software to you. And at the end of it, we will do a Q&A. So on the meeting today, you've got myself, who I think I know a lot of you from, I look after some of your accounts. We've also got my colleague Charan on the call. Charan is the account manager for many of you. And Matt Severin is one of our senior Qlik consultants, and he's going to be taking us through the software today. So let's make a start with housekeeping. As I said to those who are on from the start, we are recording it, and it will be released on our YouTube channel over the next few days. So I'll be sending another link out for people to go back over the webinar or share with colleagues, whichever works for you. Please do ask questions via the meeting chat as we're going along. If we think there are ones that are relevant enough to interrupt at that point, then we will do so. Otherwise, I think what we'll probably end up doing with most is keeping them to the end for the Q&A session. This very rarely happens, but some people like to do it. If you want to talk with us over the webinar, then please raise your hand and we can unmute your microphone during the Q&A session. Most people seem to just want to write them down, and I have actually got a few that were done in advance. So I'll be going through some of those. Right. So further ado, let's get going. So Qlik AutoML is part of the Qlik Active Intelligence platform. This is the ability to provide users with near real-time data, if appropriate, starting with taking data from wherever it's sitting in its sources. We can do creation of data warehouse automation with things like Qlik Replicate and Qlik Compose. We can put it into the Qlik catalog, and then hopefully the majority of you are using Qlik Sense to do data analytics over that data. Many of you on this call today, I know, will just have the data analytics where you are connecting directly into the sources, and that's fine as well. I just wanted to make you aware of these other pieces for those companies that it's relevant for. So advanced analytics and data science is tagged on the end, and this is what we're talking about here with Qlik AutoML. That's where it fits into the stack. So who is it aimed at? So it's aimed more at power users that want to use pre-built algorithms to build models and test hypotheses. So you don't have to be a data scientist to use this piece of the software, and in fact it's designed really to provide some of the data science capabilities to power users. So you do need to be data literate. It would help if you understand the structure of the data, but you don't need that extra expertise to be data scientists. Qlik does still integrate with the likes of R, Python, SageMaker, and so on. Should out-and-out data scientists want to use that to build their own models, that is possible too. So what is it? Well, it brings, as I said in that last slide, it brings the power of machine learning with a simple code-free experience. It's drag and drop. It's not having to write out-and-out code. It uses your historical data to generate predictive insights. and it automates many standard data science processes. So you haven't got to worry about how the thing works under the hood. It runs data through pre-configured algorithms and models and auto selects the best one. And it identifies the key drivers, which are known in the software as features, behind those predictions, and it will also show you the accuracy of the selected model. And that's what some of the stuff that Mats will show you shortly. So what type of machine learning predictions can we do with the software today? Classification. So, binary classification. Is it a yes or no answer or a true or false? Multiple classification where the target outcome is more than two categories. So we've given you the examples in some of the emails we've sent out around customer churn and employee retention. And Mats will cover some of that as well this morning. It will also do regression, which is a numerical answer where the target outcome is a number. So, expected customer lifetime value and price predictions, I think, is one of the ones that Mats was hoping to show you too, if we have the time. What it doesn't do currently, but it is in the roadmap to do, is time series around numerical and time components. So targeting outcomes with numerical values over time. That is in the roadmap. It's just not here in this first edition that we've got right now. So without further ado, quit me waffling on PowerPoint, I shall hand over to Mats. So Mats, do you want to share your screen?
Yes, thank you, Neil. I'll share my screen in a second. So my name is Mats, and I will be showing you a demo of the automated machine learning capabilities in Qlik Cloud. And as Neil mentioned just a minute ago, there are two types of predictions that you can make currently, depending on what data type your target outcome is. So if the target is a numerical value, then the prediction is called a regression. And if the target is a categorical value, like yes or no, for example, then the prediction is called a classification. I will show you both examples today. One example more in detail than the other, but I will start off showing you how to predict a binary classification target. In this case, we will attempt to predict employee attrition. In other words, we will predict whether an employee is likely to leave our company or not. So in this case, our target outcome is, or our answer is a yes or a no. So I'll go ahead and share my screen. So there are quite a few steps involved in this process. So I thought I'd just summarize them so we don't lose ourselves along the way. So we can take a look at this high-level summary here. So the first step is to create a machine learning experiment and train your machine learning model using a historical data set. The second step is then to create a prediction by applying this machine learning model on a current or future data set. Finally, I will show an example of how you can visualize these the results or the prediction results in an analytics application. So we will revisit this slide later on. Right, so here I am in the hub. You can create an ML experience by clicking the Add New button, and you'll see that there's a new option here saying New ML Experience. So we're gonna click on that one. I recommend you to keep your AutoML items and data files in a dedicated space, just because we will generate quite a few items and data files now along the way. So it's just better to keep them in a dedicated space. So we'll just give this a name, employee attrition, and then create. Okay, so let's start. I can have a lot of data sets here. The first step is to select a historical data set that already has a known outcome in order to train our model on that. So in this case, I do have a train data set, or a data set I call HR employee attrition train here. So we're going to select that one. Then the next step is to select a target. In other words, the outcome you would like to predict. In our case, we would like to predict the attrition. So this field has then the outcome, which is a yes or no, whether the employee will leave or not. So I'm gonna click on that. As you can see here, by default, Qlik has automatically selected all the other fields. In the AutoML world, they are known as features. And features, also known as prediction influences, are the attributes of the data that we are going to test whether they have an impact on influencing the target outcome. We are, in other words, looking for the key drivers influencing our prediction. You can see also that Qlik has left out a few of them. For example, there are this case here, a so-called constant, which is just a single value. We also have something here that Qlik says this has a high cardinality, and this is an employee ID field. So primary keys or unique IDs are also left out because just like constants, because they won't contribute to predicting any patterns. This type of data is not useful in any other words. You can also manually exclude other fields here. But in this case, we will leave them in as we don't know at this stage which features are the key drivers. So this is part of the experiment to find out what is driving our outcome. We can also see a summary of our experiment here to your right. So you see your training data set and the size of it. There's a limitation here to point out about the number of cells that can be used in a training data set, but I will leave that to Neil. He will talk more about that after the demo. But if the data set is too large, Qlik will give you an error message saying you can't use it. I think the general rule here is the more features or columns included, we have quite a few here, the less number of rows can be utilized. So there's definitely some data preparation or data consideration that needs to go into selecting your training data set. So I will again emphasize that this is an experiment after all. So you can review, refine, and rerun multiple versions of the experiment as you learn more about your data set. Another thing you have on the right-hand side here, besides your target and features, which you already mentioned, is the designated algorithms, which Qlik AutoML has selected based on the detected data type of your target. So here you can see Qlik has detected that our target, which was the attrition, is a binary classification data type. And based on that detection, Qlik then has suggested a number of suitable algorithms to run on your data. Again, you can deselect some of them. In this case, or at this point, I'm just going to leave all of them in. Just to briefly mention, there's something called model optimization here. It's by default disabled. This option you can tick after running the first version of the experiment. But please note that this option also will increase the process time of running the experiment. So we will skip this for today. Finally, also just want to mention here that Qlik summarizes the steps that are being taken when building and training your machine learning model in this last little information view here. So if you want to know more about what is going on behind the scenes, you can take a look here. The purpose of this is to automate it, and you shouldn't be a data scientist, but it does raise some questions. So I think you can delve into the steps here a little bit more. Okay, we will now just run our experiment. So you can see here the suggested algorithms are being pre-processed. You can see a number of, so on your right-hand side here, you have a number of metrics to score each algorithm. You can see now that our machine learning model is being trained. Right, so these scores, you see, sorry. Oh, so these scores here, the leftmost score, in this case, the F1, is the overall score of the algorithm, whereas these other ones are subsets or subsets of the overall score. You can see that Qlik automatically selects the highest scoring algorithm. So it's already selected for you. You can see a little trophy here in the top column indicating that this is the best fitting algorithm for our dataset. You can, of course, select another algorithm here if you want to delve into, in the bottom part here, you can see that you can analyze the different algorithms on different types of metrics. So I'm going to mention that just in a second, but we're going to keep this highest scoring algorithm selected. So the overall score here, F1, is a score between 0 and 1. So you want to, of course, get as close to 1 as possible. I learned that an F1 score, which is more than 0.5, is good enough. I Googled that, but you can also look at other things like the ROC curve or the confusion matrix. Of course, you can argue that this score could be better. But again, you can always, you see the option here in the bottom here, you can configure, where you can then deselect some of these features that hasn't scored as high as others, and then you can run a second version of your experiment. But we're going to leave that for now. So just to mention the ROC curve, it shows how good your model is at predicting true positives. So the dashed line here in the curve is equal to the flip of a coin, or if your data is completely random, and it's not very useful to use as to train your machine learning model. In this case, we do have an okay curve, I would say. Of course, again, you would like to come as close to 1 as possible, or 100%. But I think this is good enough for our demo. Also to mention the confusion matrix, which is another graph that shows how or the accuracy of the model, and this gives insight to the types of correct and incorrect predictions that are being made. So you can see how many true positives or true negatives or false positive and false negatives you have being able to detect. Again, it depends on the use case here. I think the classic example here is if you're trying to predict cancer, the cost of predicting a false outcome in this case is then a matter of life and death. So it's quite high costs and stakes involved. In our demo today, we don't have as high stakes involved, so we can settle with this score here. But just to mention that you can use this depending on what your use case is. And as always, this machine learning predictions, you're also going to ask yourself, are you informing a decision, or are you trying to automate an entire decision process? I think in our case, we will just use this information to inform our decision. Right, just before I deploy this machine learning model, just to mention something called SHAP. So SHAP values, they score each feature, or in other words, each of these fields, each feature's importance or the contribution of a feature in influencing the prediction. We will take a deeper look at these values later on, because we will use these when visualizing our results. More on that later. Let's just deploy this. So you can see here, by default, Qlik gives it a name. We'll give the experiment name, the version number, and then the algorithm that was selected. So I'm just going to go ahead and deploy. We can open it straight away here, but just to illustrate, I will go back to the space. We go back to our space. We can see now that 2 new types of items have been created. So first we had our experiment where we trained our model, and then we have the deployment, which is one of those versions or models we selected to deploy. So just to kind of recap again, we have created an experiment. We have trained our model using historical data. Now it's time to use that model to create a prediction on a current data set. So I will click on our ML deployment. You can see a high-level overview of the model here, what features was used, and some other information. If you click on dataset predictions, you can see we have no predictions created. So we'll go ahead and create a prediction. Now we have our model. We want to apply it on some current or future data. So we will select something that Qlik calls an apply dataset. So I'll just filter here. I have prepared so that was our historical data. Then I prepared an apply dataset, which I can be using to apply the model on. So we're going to name it also. So again, by default, it gets the file name here with the prediction suffix. You can select either you want to save it as a QVD or CSV. I'll keep it as a QVD. And we can say confirm. Now you have a few options here before you go ahead with the prediction. The apply dataset option here is a copy. It creates a copy of your current dataset, but including a row index auto-generated by Qlik. So you can link the results with the current data, because if you don't have a key in your dataset, we need to create that key in order to link our results with our current dataset. So this option is if you don't have a straightforward key. So you can see here that Qlik can then create an auto-generated row index. However, in our case, we do have the employee ID, which uniquely identifies every single data point. So in our case, we don't need a applied dataset. The next option is the SHAP values that I briefly mentioned. We want to keep that ticked. We will use them to analyze the key drivers or the so-called prediction influencer. The other options here we can skip. This one is just the same type of data in a different format. So I'm just gonna select this one. We don't need this log file here. So, and we wanna link the two sets using the employee ID. So I'm just gonna click predict. You can see here in the status field that it's running, shouldn't take too long. We can also see what types of files we created along with the prediction results. Okay, it's already done. Go back to our space. And let's see here then if we can find here. So like I mentioned, we created our prediction results. It gets its separate QVD file. And we also have the SHAP values that I'm gonna explain a little bit more soon. So we have those two, and this prediction results, like I mentioned, are going to be linked to the apply dataset. It's gonna make more sense. I already prepared an app here beforehand, so we can take a look at the data model just quickly. It's a very simple data model. Shouldn't scare you away. Just to illustrate like what did we generate, what did we do. So here again, here's our current data set where we had all these features, but we didn't have an outcome. So we used our machine learning model and applied that on this data set. This generated a prediction results. We can just take a brief look here. So you have for each employee, we then have a predicted attrition. Are they leaving or not? Yes or no. We also get a confidence score. So here we can say that our machine learning model predicts that there's 82% chance that this employee here will leave. And there's about 18% chance that he won't leave. Then I added this extra field here just to group them together to have some kind of grouping. But yeah, so these are the standard fields, the four first field here. And then finally we have the SHAP values, which I'm going to take a look at now. So if we go to the user interface here, I have created a SHAP value analysis. So this sheet is inspired by Qlik's own tutorials and demos that you can find either on their YouTube channel or on Qlik community. I also recommend looking at the courses on learning.qlik.com for more information about these type of metrics or machine learning in general. So SHAP is then a metric to score the contribution of each individual data point in predicting the outcome, one direction or the other. So in plain English, a positive SHAP value here for each feature means a positive impact on our target. In our case, this means that the employee is likely to leave the company. A negative SHAP value means a negative impact on the target. In other words, that the employee is not likely to leave the company. So SHAP values that are close to 0 means they have little or no contribution to the outcome, whereas strong positives and strong negatives, so the outliers here, or if you have a wider distribution of them, means a strong influence on predicting the outcome. So if we take the job satisfaction field or feature, when we look at the overall score here, it doesn't, I wouldn't say, it's quite an even distribution. It's hard to kind of say anything about this. So we do want to delve into each of the values in the job satisfaction field. And now we can actually start seeing some patterns here. So we can see that if your job satisfaction is at the minimum here or very low, you can see that we have a positive impact, meaning employees with these scores are more likely to leave the company. But then we have the highest job satisfaction score here. We can see that it tends to lean more to the left, that these scores, if you have these scores, they tend to indicate that you're not or not likely to leave the company. So just to give you an example of what SHAP values is and how you can analyze them. So what I've done then is I've taken some of these top features. So I focused on them because I see that they do play an important in predicting what we're trying to predict. And then I built my dashboard off of that, if that makes sense. So yeah, the point of analyzing SHAP values is to identify key drivers, and with that information, we can build reports and dashboards, focusing on the strongest influencers, like I've done here. For example, job role, or whether someone is working overtime seems to have a great impact. If you don't have a stock option level here, also seems to have a great impact on leaving the company. And here the KPIs just show you the number of predicted leavers, which then gives you a rate here. And also I've grouped them then into departments and job roles here, which you can start analyzing. Even though the most common leaver is this job role, we can actually see that sales reps have a higher attrition rate. So there's different ways of delving into this. I'll just quickly also show you, because you get such detailed level of these predictions, you can also do some detailed analysis. So if we can select, I've sorted the employees here with the highest probability of leaving. So if I just select one of the employees, we can then start comparing that employee to the company average. This employee has a very high probability of leaving. Might not be surprising, is a relatively young one, only 1 year in the company, for example. Seems to have quite a long distance to the office. Maybe has an effect. I don't know. I guess we need to go and talk to that employee. Also can see that the average monthly salary is way below the average. Right, so that was just to give you an example of how you can use these prediction results and build analysis. And yes, this was a fictional data set, also just to, I think it was originally IBM who provided this. So it's out there if you want to look at this particular data set yourself. Right, so that was the binary classification. Now the process for running the experiment on a numerical target and creating the predictions for which is known as a regression are almost identical. So I will not take you through the whole process again of showing you the regression example. It's very identical. One of the main differences is the metrics used to measure the accuracy of the machine learning model looks a little bit different, but from a user experience perspective, you follow the exact same process. I can just show you. So the regression example, my numerical target was I used a selling prices for used cars to try to predict prices on a data set. And if you just delve into, is it this one? ML experiment. Yeah, so just quickly show you this experiment. So we can see here that Qlik has detected that our target is numerical, so it has given the regression analysis, and we have then another set of algorithms suitable or suggested by Qlik. In this case, we actually have very high accuracy in predicting the prices here, almost 90%. So I'll go and show you how you can visualize this.
Matt, just to jump in,
Yeah.
one of the questions has been, can we see what the prep data looks like for the regression example?
Yep. Let's see. That would be the prediction. Predict. Yeah, train. So this is actual real data from some online used car business called Car Deco. It's also out there. You can easily find if you Google a little bit. So do we get an overview? So here we have a car model, brand. Yeah, so these are basically our features that we want to check. And then where's our selling price? There's our selling price here. So here are individual basically transactions then and the selling prices. If that answers the question. So it's just a numerical target. Other than that, the features are going to be analyzed as any data set. Yeah. So if I'll just quickly show you how you can visualize that. So again, I've done one of those SHAP value analysis. This might not come as a surprise to you when we're talking about used cars. Of course, things like age, brand, fuel type, the number of kilometers driven is going to play an important role, and it does. So here I've just built a simple dashboard that we can then delve into different brands and models. We can see then which are predicted to cost more than others. I have the average here. So if we take, I don't know, we take Volvo, for example, you can then get an average predicted price, and then you can filter on other types of features here. I think when I did this, the next step would be, and I think Neil will mention this, is can you do what if analysis? Because you can see here that my historical data set and my current data set is limited in the number of, let's say, possible combinations of data. So what if I want to say, okay, what's the predicted price of a Volvo that is 20 years old and that has a manual transmission? I don't have that in my data, so I can't select those values here. So this is where this what if analysis comes in, and yeah, I think we're gonna mention it soon, but it's something that Qlik is working on. So that type of functionality should come soon, and there will be tutorials and labs out there as soon as they have rolled this out. Okay, I will stop presenting. That marks the end of my demo.
That's great stuff. Thanks very much, Matt. Oh, I haven't got my camera on. There we go. No, thanks very much indeed, Matt. Appreciate that. Let me just go back to PowerPoint slide, share, and let's share that one. So questions was next on the agenda, and several of you have been posting some into the chat. So thank you very much for that. I've got some that were sent in advance by people who couldn't attend, and I've got some additional ones that guys have emailed to us whilst we've been presenting. So first of all, one off the top that we've got in the chat is Ross. So Ross has asked, and I think I can answer this one. Can we, where are you, Ross? Can AutoML be created in a Fort space? So my gut feel is the answer to that is no, Ross. Mainly because the data would need to go up to the Qlik Cloud to go through the algorithms. But we will find out for certain what that is. But yeah, my gut feel is no. What else have we got here? We've got our what if analysis available. Okay, well we just answered that. I understand that's very soon to come out, Matt.
Yeah, yes,
Looking at the chat.
That's what I heard. Yep.
Yep. So I've got Mark has asked a question. I think one or two of these questions might be from people who joined a little bit late. So Mark's saying, does this replace R and Python? No, it doesn't. I think if I go right to the top of when we started, so this is aimed more at power users that want to use those pre-built algorithms. So data scientists can still use this. Clearly they can, and it helps them to speed up the testing maybe of some hypothesis. But yeah, if you want to be data science, you want to get underneath the hood of it, then no, things like R and Python and SageMaker are still appropriate, and there will still be links to them from ClickSense. What have I got? Sorry, questions. So other questions I've got. Have you got anyone else using it? Yeah, the answer to that is yes. We've got a handful of companies who are either beginning to trial it in the free version or are running a proof of concept. One of them, Chris, are you on the call? Are you able to jump in and explain what one of them's doing? I'm probably wrong to mention who it is, but
yeah, so we're looking at it to predict whether opportunities are going to close win. So in that, what we found is a lot of it is just getting the data right, getting it in a decent format. You can't have things like nulls and missing data, and that's a lot of the prep work that you've got to do up front. And it's obviously something that you don't see as part of the demo because it's the boring part. But having the data in the right format and knowing what to feed, what records are truly representative of opportunities and alike is definitely important. And obviously when you're doing things like predicting won or lost, you've got to provide it both. You've got to provide an accurate representation of your data. Don't say I want 50% loss and 50% won opportunities, and that's the data I'm feeding it. It's got to be in ratio of your true won and loss percentage. But then also it's identifying the correct fields, the correct drivers, and that's where Neil mentioned earlier. The people using this should be data literate. There should be people that can argue with the data and find out what those driving features are, because that's going to improve the accuracy of the end result. So, region as an example isn't a true driver. It might be a passive driver, but it's not a true driver of what's going to drive a won or lost. Whereas something like the opportunity value compared to the lifetime spend of a customer, looking at the number of interactions per week, they are all the things that are going to influence and have a positive or negative effect on those. So that's the process that we're going through. And it's the other thing to mention, it's a constant evolution as well. It's not something that you will do once and then you kind of ignore it and it just predicts yes or no. You should be constantly trying to improve those features that you're looking at and argue with it.
Okay, no, thanks for that. Sorry, people, I had to rush off because Of course, in the middle of a webinar, the Amazon man does deliver, doesn't he? Sod's law. So other questions we've got. Paul has written in saying, seems I got the time wrong. No problem, Paul. Is AutoML only on Qlik Cloud, or will it be on-prem? So for the moment, it is in Qlik Cloud SaaS. So, and that generally that is the way that we are pushing customers towards SaaS if they can, to even if that's hybrid models as well. Because that's where, from our perspective, the majority of the funding is going currently into making that SaaS offering more and more strong. So, Paul, we can chat to you about how that would work in practice, probably offline. But let me get back in touch with you on that one. So, I had another question on that. Is this only for SaaS? I've also got, are there any limitations? So I've actually got a slide that probably shows this a bit better, which is around the commercials. So we explained to you that included within QlikSense SaaS, you get an unlimited number of experimentations. You get up to 2 deployed models in production. The data size, so the actual number of cells, is something to consider. You get 50,000 in the free version, so the annual cost is free. But then as you scale up and you want to do more and more of this sort of analysis, then yes, there are different versions that provide you with additional deployed models, much larger data sizes, and of course that comes with a additional cost as well. So we can talk people through those on a one-to-one basis as that becomes appropriate. Other questions we've got in the chat. So yeah, Sean, it'd be nice to have a follow-up session in data prep. So yeah, we'll do that one-on-one with you guys, Sean, because everybody will have slightly different questions. I think that's a bit difficult to cover off in today's audience. What else have I got, Paul? Is there anything else that could be on demo? So I think we've answered all of the questions. Yeah, we got asked, are we recording the session? Yes, we are, and I will be sending that out as soon as we've got it into onto our YouTube channel. So I haven't got any other questions. Does anybody want to join in and ask a question over their mic? Is when people normally run for the hills and ask these sorts of questions. No, I don't think so. So yeah, I say I will send over a summary of what we've talked about today. We can ask that point, are there more detail that you want to go in? We can take that offline on a one-on-one basis. But thank you very much for attending. Please look out for the other webinars that we've got coming up. And do make suggestions if there are other topics that you would like us to cover, because we're always looking to try and keep these relevant to you rather than just things that we think might be useful. It would be useful if there are actual use cases that people want to see them around. But without further ado, thank you very much, Matt. Thank you for your time, and yeah, thanks for your time today in joining us.